as you guys get further along, they don't use sine to the -1 or cosine to the -1 or tangent to the -1. They use what's called arc sine. Arc sine, arc cosine, arc tangent, all mean inverse tangent. That's what they all mean. Okay. So you might see arc. Oops. So I can spell arc. It's still 13.4. I'm doing a little extra piece with this stuff here. So what happens is they can write it out different ways. It's just another way that you're going to see it written. So if you see arc cosine, it just means what angle has a cosine that. It means the same thing. Bless you. It means you can do stuff like this. Okay. What angle has a cosine of 1? Means the same thing.
0.
What angle has a cosine of 1? Guys, let me give you a little secret here. When you see ones, negative ones for sines and cosines, think quadrantals. Think of your ordered pairs.
Pi.
If you see a 1 or a -1 with a tangent, what's it always going to be?
Pi. What?
Wait, you're grateful.
Bless you.
Pi?
Let's back this up here. Guys, yeah, you know you have a test on this on Thursday, right? Okay. So when you see ones, -1s and 0s for sines and cosines, think quadrantals. If you see a 1 for a tangent, what is tangent in terms of x, y's, and r's?
It's y over x.
In order to get y over x to equal 1, what do both y and x have to be? The same thing. Okay, they have to be the same. What ordered pair always gives you the same? The 45s. So tangent being 1 is always going to be at a 45, or tangent being -1 would be at -45. Works every time. Those are the trick ones, but they should be quick because they're right on the quadrantals. There's no real thought that you have to put into it. It's just a matter of which ordered pair. 1, 0, 0, 1, -1, and so on. Okay? Remember how those things through. So if I'm asking you, what's the arc cosine of 1? Where's cosine 1? 0.
Yeah.
So I was right.
Well, you're on that, right? But I can also do this. I can do a composite.
Well,
Correct. So here's what happens. You think of it in terms of order of operations. Order of operations tells you to work on the inside out. You work with the inside of the parentheses first. So in this case here, you're asking what angle has a sine of √3/2. You do not get a calculator. Do not use it. You know that, right? Thank you. So you have to sit there and think, what triangle has √3s and 2s? 60s, 30, 60s, and 90s. So you start with that idea. Okay, so this is my inside 30, 60, 90. Which one of those gives you 60? So the arc sine of √3/2 would be 60 degrees. Okay? And what's the tangent of 60?
Oh, partnership.
√3/1.
√3.
It's composite. Work the inside out.
Okay, that's not. It looks a lot worse than it is.
Exactly, it does.
Yeah.
It looks a lot worse than it is because, again, we haven't seen this. This is a pre-calc thing. But you get to do it.
Can't wait.
No, I sense the sarcasm. I sense the sarcasm.
No,
Almost
it-
fine.
It looks pretty cute.
Okay.
Can you like double composite it or like change on that of that?
I think you can, but I don't know why.
I'm saying, that'd be wild. What? I'm just asking a question. Oh, dude.
What's the cosine of the angle that has a sine of 1/2?
Wait, hold on, let me draw it out.
So 30.
Hold on.
Work on the inside. What angle has a sine of 1/2? They're 30, correct?
Yeah.
Okay. So that means what's the cosine of 30? What is it?
Root
3 over 2. Yes, ma'am. Try not to be. You could,
Okay, that's
but we
not
try
so
not to
bad.
be. Okay.
Like what instance
Next year.
Aha. Yes.
Yes, sir.
Since it's like inverse sine, wouldn't you do like hypotenuse? Wouldn't it be like a different angle? Since, oh wait, never mind. I'm thinking about cosine.
And that's a whole nother ballgame when you do that. Okay.
Wait,
Yes.
so if it's like sine -1, you just treat it the same as if it's like sine?
No. Remember, the inverse function means what angle has. What angle has the sine of 1/2? So this is the exact same thing you did yesterday. And then I was saying, hey, what's the cosine of that angle you just found? That's all.
Can you go back and explain the arc cosine again?
Arc cosine is the same thing as inverse cosine. Means the same thing. Where? What angle has a cosine of 1? Think about ordered pairs. Cosine goes from here to here. Whenever you see a 1, that means it's going to be on a quadrantal. Which one of those is cosine 1? Which one is cosine? Which one comes first in the alphabet? The x value is cosine. That's right. I got out of sequence here, sorry.
I got it. No, I don't.
You can
Can't be that.
I don't know, I'm done. What angle has the sine of root 2 over 2? Oh, sorry.
Wait,
All right, Kobe's still working.
Oh,
Still working.
I see the smoke coming out of the ear.
Hey.
listen, Joe.
Oh, come on. How many times have you played that card on me?
Probably a lot.
Yeah, exactly. I get 1.
Add a few. Okay. Add another time. It's okay.
It's just,
I think I got it.
I don't think you.
It just looks a lot worse than it should be.
The ampersand answer seems so simple.
Remember,
That's correct.
what angle has a sine of root 2 over 2? What angle has a cosine of root 2 over 2?
45.
What's 45 minus 45?
0.
What's the tangent of 0?
0.
Go to the next problem.
Yes! Got it.
Wait, didn't you for your tangent?
Yeah, because remember, tangent goes between, it means 0 radian also. 0 degrees is the same thing as 0 radian. Okay? I don't know. I'm trying to think if I can.
Let's do it.
No. No matter.
Go this
If
way.
I capitalize it sometimes and capitalize it some other time, not sometimes, it doesn't matter.
You can switch it up on us and go like sine -1. No. I'll show you.
All right.
Okay.
Game on.
Got it.
What angle has a sine of root 3 over 2?
60.
What angle has a sine of 1/2?
30.
What's 30 plus 60?
90.
Go to the next problem.
Okay.
Once you get the first one, can you just like yes, the second one again? There you go.
No, you see what happens is you still got to show how things set themselves through.
Well, you could.
We actually do a lot of verify stuff in about a week or two. We're gonna do a lot of simplified verify style problems thrown in there. What I want to do here today is start giving you guys some of this stuff, because the way I'm looking at it is we will have to go and test Thursday. Friday they have that ice cream social thing, which means my 12th hour is going to be decimated. Means there's going to be nobody there. It's honors out for 2. I don't know. If you get invited to ice cream, you can get ice
These
cream.
are 3.5 GPR.
So if you really, want to be nice, you can bring me a sundae. I like ice cream.
If they let me get 2 of them.
Thank you. You're a good kid today. Other days, not so much. So what we're going to do here is we will do calculator, non-calculator. Okay. Think about the stuff that we would do calculator.
A lot of stuff
The one
in
thing
there.
that-
The couple things we did like last night. A couple of those word problem style ones we can use with the calculator. The what else was there? If right triangle stuff, I might hold off on law, sine, law, cosine, and just let that sit to the final, because there's really,
Yeah.
it's not that.
That was this chapter?
Yeah, it was. It was seemed so long ago, and that's the other thing. It seems so long ago, and it only has that one little thing. And to be honest with you, when we get to the final, that formula is given to you, so you don't have to memorize it anyway. So I think I might just wait on law, sine, law, cosine, and go from there. 10 o'clock. What we'll do is we will revisit when we get close to the final about how you can find that ambiguous case by doing that. Remember how we did the supplement? We just bounce it around. So I'm not going to throw that on this test part because it takes too long. And with I know Friday not being able to have anybody in here, I think it'd be just calculator, non-calculator Thursday, be done with it.
Wait, so on Friday, the ice cream goes in at 12th hour, right?
It goes 12th hour, but what happens in 12th hour is that they will have, I remember seeing a schedule, well, I'll show you guys again later. They get rid of flex, they move 12th hour to flex, and then after the first 10 minutes of whatever it would be, then they release people for like the last half hour of the school day then.
Wait, so like 12 hours long?
No, it's still the same. Or do they have flex?
They probably have flex.
I think they do have flex. I don't remember. I'll have to look at my email that I might have deleted. I guarantee I deleted it.
I thought flex and 12-hour switch,
They didn't.
and then
I don't think they didn't. I don't think they did that.
switch, and then like
I-
after 12
I
hours,
don't know.
and then go to flex.
There's an email and I deleted it. Anyway, so we'll do the calculator, non-calculator. Non-calculator wise then, is basically everything else. What angle has? Composites. Pieces like that. The quadrantals parts. As you go through the rest of it then, as we finish that out, that gets us in, like I showed you guys yesterday, the next step. On Friday, we will solve equations, which is using these inverse functions, but we're going to solve the equation. Like the one we did yesterday where it was 2 cosine x minus 1 equals 0, and we solved it in radian. Excuse me. We're going to do the same thing. We'll solve in radian, we'll solve in degrees, and we do a bunch of stuff like that. We'll do that for a couple of days. It'll probably go Friday, Monday, and then Tuesday, we'll start graphing. We'll graph sine, cosine, Tuesday, probably Wednesday. Then we, remember, do I do shifts first, and then we go back and do tangent? So yeah, we'll be graphing for the next week or two.
Wait,
We will.
after this
What's that?
test, after this quiz thing on Thursday.
No. You won't need a calculator at all for this next grouping at all. Okay. The stuff that's in, basically chapter 14. The equation stuff is all built off the unit circle. Everything has to line on the unit circle, otherwise it won't work. So if you know how to draw your triangle, you'll be fine. When you go to the graphing, the hardest part is cutting something in half, and then just working with some simple fractions on that. I have been known to allow people to use the dumb calculators for the fraction parts, but not using the graphing calculators because it gives you too much information from there. But it's very, very, if you follow the process for what we do for graphing, it's ridiculously easy. It's just a matter of the setups. So I made this little sheet, and it's a pretty decent review of 13.2 to 13.4. I know the 13.1 really wasn't on here, but that's just right triangle stuff. I mean, that's really pretty easy. And here's the inverse. Where's the inverse? Did I not get the... Oh, I didn't print the second page that had the inverse stuff. All right. So not all the inverse stuff is on here. I'll give you that stuff tomorrow. Sorry about that. Yeah.
It's ready.
We'll do more. I just now realized I didn't print out the second page for this, so we'll do the inverse stuff, and I have a couple more of these composite style. We'll just put those together tomorrow. Is that all right?
Yeah.
We'll answer questions on these, and then we'll just build in the composite stuff in class, and then we'll be ready to roll for Thursday.
Pretty impressive, right?
Yeah, I guess.
Alrighty.
Do I want to give it?
That was